Lesson 21, Exponents Review. Here's part 1. Add or subtract. Let's go over just one example, box A. Here we have 7ABC minus 3ABC. And our answer here is 4ABC. Here's part 2. Simplify. Rewrite terms with negative exponents as fractions. And notice that it says, leave problems G and L in exponential form. Let's go over box G. 3 to the negative 4th power times 3 to the negative 2nd power. And since they have the same base, we can use a shortcut. Keep the base and simply add the exponents. So our answer here is 3 to the negative 6th power. Now let's write this as a fraction instead of using negative exponents. So our final answer is 1 over 3 to the 6th power. Let's go over box K. R to the 5th, S to the 3rd, divided by R to the 4th, S to the 8th. Let's take care of base R first, then we'll take care of base S. R to the 5th divided by R to the 4th equals R to the 1st power, or just R. S to the 3rd divided by S to the 8th equals S to the negative 5th. Now let's rewrite this as a fraction instead of using a negative exponent. And remember, this exponent of negative 5 applies only to the S. So our final answer will be R over S to the 5th power. Here's part 3. Evaluate. Let's go over 2 examples, starting with box M. 6.25 times 10 to the 5th. And this exponent of 5 tells us to move this decimal point 5 places to the right. We only have 2 digits to the right, so we need to add 3 more zeros. Final answer here is 625,000. Here's box O. 8.4 times 10 to the negative 3rd power. And this exponent of negative 3 tells us to move this decimal point 3 places to the left. I have 1 digit to the left, so I need to add 2 more leading zeros. Now I can move the decimal point 3 places to the left. 1, 2, 3. There's my new decimal point, and let me add 1 more leading zero. Our final answer here is 0.0084. Here's part 4. Write each number in scientific notation. Remember, target your new decimal point first. Here's box Q. 525,600. Our old decimal point is right here. Our new decimal point is right here. Count how many decimal places to get to the original decimal point. We have 1, 2, 3, 4, 5 decimal places. So our final answer will be 5.256 times 10 to the 5th power. Let's double check our answer. Count the number of digits between the new decimal point and the old decimal point. And we have 1, 2, 3, 4, 5 digits there, which matches our exponent. Finally, box S. 0.00405. Here's our old decimal point. Target your new decimal point first. Where will it go? It'll go right here. Now count how many decimal places to get to the original decimal point. And we went 1, 2, 3 places to the left. And remember, since we're going to the left, it's like going to the negative side of a number line. So our final answer will be 4.05 times 10 to the negative 3rd power.